Welcome to the ArcGIS Insights Python R Scripting and Advanced Analysis presented by Arthur Haddad, myself, joined by Dr. Linda Beal and Apurva Shah, all part of the ArcGIS Insights team. We're going to start with a basic overview of ArcGIS Insights so we all have the same foundation. And then from there, we're going to dive straight into analysis and data science with Python and R. Then we'll wrap things up with a road ahead session. So with that said, ArcGIS Insights. The three basic premises to ArcGIS Insights. One is provide self-service visual analytics with multiple data types and sources. That's kind of important when you're defining a modern location analytics platform. Self-service location, visual analytics, as well as supporting multiple data types and sources is a critical component of a modern platform. Visualizations can always be quantified using accompanying descriptive statistics, and we'll demonstrate that later on in this presentation. Of course, exploratory analysis is important and can be extended even further with other types of analysis, specifically graph analysis, predictive analysis, other open data sciences, and whatnot. To dive into self-service analytics, there are some tenets to what we're describing here. One, we want to always send the computation as close to the data as possible. In some cases, the data is live or transactional. Other cases, it's based on a snapshot in time through ETL processes or whatever. Both cases we can work with ArcGIS Insights. Data sets themselves, once in the workbook, we can do a number of things with them. We can join those data sets in traditional SQL manners. We do not flatten out those tables. We continue to work with the tables as they are raw in the relational space. We allow for many types of joins, and we can join not just on the traditional strings, numbers, and temporal values, but we can also join on spatial values as well. Of course, with Insights, we take GIS to the next level and allow for multiple shape fields per data set. This allows us to reduce the number of storage demands, as well as additional geocoding can be done with using enable location. Some of the key features that we want to highlight are data connections. We mentioned earlier, multiple types from numerous sources, all within the same workbook to enable your analysis needs. Another is visual analytics. Now, this is a little bit different than data visualization. This is performing both analytics and data visualization in one step, understanding and analyzing the data easily and quickly sharing those results. And definitely, we want to make sure that we understand data science is a key aspect of what ArcGIS Insights can do. We extend both analysis and visualizations using your kernels, both Python and R, directly inside of Insights. Specific to the data connections, we enable data access directly with those data sources. And like I said earlier, we allow for multiple data source connections simultaneously, and we directly connect to the data wherever possible. Processing and storage is also important. What we try not to do is affect the tables where they exist, but we do make use of a number of caching techniques and dynamic SQL techniques where we can work with the data. And of course, as it relates to data, whenever we have results or data that's been brought into a given workbook, sharing or exporting those results is a very common thing, and ArcGIS Insights enables all of that directly from its interfaces with a single click or two. ArcGIS Insights exists in the three different deployment models. Support for on-premises through ArcGIS Enterprise, support through a managed SaaS subscription through ArcGIS Online, and also includes an Insights desktop version, which can be activated with any Insights license in either Enterprise or Online, and can connect to multiple enterprises and online. The data that we do support, obviously flat files, relational databases. In terms of flat files, we support all the ArcGIS formats as you would expect, feature layers, geodatabases, shape files. We extend that even further with GeoJSON, Excel, and CSV files. The different databases, we support the most common ones, such as Microsoft SQL Server, Oracle, Postgres, PostGIS extension to PostgreSQL, as well as SAP HANA. And of course, anything that you can connect to with open source Python scripts or R scripts directly from within those kernels allows you to work directly with additional sources or even additional algorithms and data structures that only Python and R can do. So Insights Desktop enables you to download this. This is a simple download directly from our product webpage. And once you download it, install it on both Windows and Mac. We support both Windows and Mac with the desktop version. It's a simple activation, and from there you can easily connect directly to any databases you want, or even your own Python and R kernels. ArcGIS Enterprise also allows you to directly connect to databases and your own Python and R kernels, your Jupyter setup, if you will. But ArcGIS Online has some differences in that, one, you cannot connect to on-premises data sources yet. It's for obvious security reasons, as well as Python and R as of today. We're working towards that in the future. Specific to domains and subtypes, we do connect to geodatabases natively. And as such, we want to support the new types of schemas, such as utility networks, in support of coded domains, coded value domains, as well as subtypes, and working with these different things. Utility network is becoming very popular, being used heavily in multiple industries, specifically the utility industries like pipelines and oil and gas and whatnot. So just wanted you to know that even though we support connections to these geodatabases, we actually go down further and support even more as part of those connections and work directly with the data inside of Insights. As it relates to visual analytics, I alluded to discussions of data visualization versus analysis and then visualization. Visual analytics combines both of those things into one move. It allows you to select the different fields, start with the variable that you're interested in. So rather than dealing with the layer as a whole, Insights breaks it apart and allows you to work directly with the fields of information. Once you select the field that you're interested in, it's a simple drag and drop operation that enables you to directly connect or directly analyze that piece of information into the format that you actually want. And of course, here's our little mascot, Dr. Drag and Drop. He's a real cool guy. Of course, once you have those visualizations, you can begin to interpret the results, explore those results, or even change the view or question with a single click. Once data is brought into Insights, it's all about being data-driven with your analysis. One thing that we do behind the scenes to make things easier for you, as opposed to a pre-process step, is we dynamically create a semantic model out of your data to include the spatial dimension. It's important that we recognize not only qualitative, quantitative, and temporal, but that spatial dimension as a first-class citizen with all of your analytic needs. Simply by dragging those onto a drop zone on the page itself, based on the semantic model that has been created, we now know the intelligent defaults that can be offered to you and the types of charts or visualization that you can do, whether it's a map, a different chart, or even a pivot table that we can create on the fly. Once you drag that on there, by default, it drops it. For example, you select a temporal value, a date time field, you drag that on. We know that because it's temporal, a line graph would probably be best, a time series, and that would be your default option. Of course, there are many types of visualizations available, both spatial and traditional through charts and different types of graph options. All of those are available in a little cheat sheet that Linda here has created for us, and it's available for download today off of our product webpage. So all of this is available today. An interesting difference with ArcGIS Insights as we go down the road of defining that modern location analytics platform, which is an evolution from the modern analytics platform, every step that you take is recorded for you in the form of these models. These models are built behind the scenes. I see that there's a little problem with the slide here, but we'll ignore that for right now. We'll show you that in just a little bit. Either way, these models are created. Every drag and drop is recorded for you. All the parameters are recorded, and these models can be repurposed, reshared, and then brought back in with new data sets and rerun. And of course, with ArcGIS Insights, in addition to traditional analysis, the most common analysis, and storytelling techniques, there are many other types of analysis capabilities that we have. And with that said, let us take a step back now that the overview is done, turn it over to Dr. Beal, and we'll get right into the analytics. Linda.
Okay, thanks, Hart. So, I'll talk a little bit, as you said, about the analytics that we do in Insights. And first of all, I want to start with the process of how we turn that data into answers. So really, and particularly for those of us who've been working in GIS, we're very much used to working visually. So interpreting data is much, much easier when we actually see it displayed. We're seeing that traditionally as a map, but we may be seeing it as a chart, or even a table is allowing us to see that kind of pattern. So if we look at the example we have here, I'm showing a chart here of different box plots. We can easily see the distribution of that data. So visually, we're able to pick out that the pipe diameter of transmission lines is slightly skewed. We see that there are more above the median value than below, and so more fall into the first quartile than in the third quartile. So we've picked out that piece of information, those statistics, just from that image we're seeing of the box plot. The fact that we see that there are upper outliers shows us that there are a few lines that have a significantly larger diameter than most of the transmission lines. So you see how we're able to interpret the information from this chart to pull out all of that knowledge that's in our data. But another part that's important, as well as visualizing your data to help us pick it out, is to actually quantify what you're seeing. What we don't want to do is look at patterns, look at pictures, charts, maps, and actually sort of incorrectly interpret it. So we make sure that we actually add in the statistics on the back of every single one of the cards that we create that allow you to actually quantify it. We also give you pop-ups throughout that will allow you to understand what each of those points is showing you. Everything is completely interactive in all of our charts, maps, and tables. So you see here how we see all the information. And on the back of the card, we have those statistics that allow you, as I say, to quantify what the box plot is actually showing you. Another important part, as part of what we're doing as our analysis, is that we actually give you the output of all of these visuals that we're creating as we're working through it. So I wanted to take the example of the box plot because that's a very good example that shows you how much actual analysis, manipulation of that data is going on behind the scenes. So if you look at this slide here, the one on the left is actually what we're starting with in terms of the data. So I have the line type and I have the pipe diameter by each of those line types. Now I want to understand the distribution of that pipe diameter across each one of those line types. So box plot is a great way of us understanding the distribution of that numeric variable. So here we're looking at how much variation is there within those pipe dimensions. So you could then further refine that to take the categorical variable of by each one of the line types. So using the box plot is going to give you a description of that distribution along with 11 different statistics. So that's the table you're seeing on the right-hand side of all of those values that's showing you that real distribution, so those statistics that are contained within that analysis that you do when you're creating a box plot. So just from that numeric variable, you're seeing that breakdown of the minimum maximum count of outliers, both your upper and your lower outliers, your upper and lower whiskers, your median value, your first quartile and your third quartile. So we're giving you that result visually. We're also giving you that result data set. And that's an important part to remember as part of your analysis because you can use this result data set. So with other of the types of cards that we can create, it will be potentially pivoting your data, aggregating it by different variables. All of that is a way of sort of manipulating your data, giving you a whole new data set that you didn't previously have. So I just wanted to call out that you have all of that within your data pane, having created the cards. So use those. You can join those. You can use them as if they're a brand new data set. We won't be filling up your database or even your desktop computer if you're doing it locally, because we're creating views on the data. So it's a very efficient way of storing that data, but at the same time, it's giving you that functionality to work with it. Of course, if you wanted to share out that data, you can. You can share it back to your local machine. You can share it back to your portal. So you can save these result data sets, or you can just keep those stored as views within your workbook that you're working in. So the next thing that I wanted to step into is something called link analysis. It's really a sort of a subset of network analysis. It uses graph mathematics behind the scenes. So you'll probably hear all of those words used in conjunction with doing link analysis. And the idea of it is it allows you to evaluate relationships, interactions, and connections within your data. So these sort of things are traditionally done with numeric variables. We can understand those relationships and interactions doing regression. We can look at it on scatter plots. It's a lot harder to do that when we're starting to look at categorical variables and we're trying to understand different features, different complex interactions within data that we have. So how do we look at a link analysis chart? So first of all, it's using nodes and links. Obviously, the nodes are where the links are joined in, and there are different ways that we calculate how that this graph is actually made. Centrality metrics is the way of telling us which is the most important node within that graph. And there are 4 different ways in which we can measure that centrality metric. So I'm going to step through all of those as we go on. There are also different layouts that can be used that allow you to better visualize the relationships within the data. So centrality metrics is actually changing the calculations, and then there's the visual layouts that change the way in which you look at it. So there are a number of different applications that you can use for link analysis. As I say, it's about finding the most important things. It's about finding those relationships, interactions, identifying the most influential people, for example, within a social network, the infrastructure points of failures, or even sources of disease spread. So first of all, let's just look at how we visualize that data, so the different layouts. So there's 3 different layouts that we have within the link analysis. So you can have force directed, and this is where you find that your nodes and edges are evenly distributed. So links have a very consistent length, and it's very effective at pulling out where there are patterns within your data. You will change it to a hierarchical one if you want to see that kind of that traditional organizational layout where you see things flowing down. So, you know, you've got your big scary boss at the top, and then you've got all the worker bees coming down from there. That's the way that we'll use a hierarchical structure, or to see where things are flowing down from, which is the key person at the top of something. A radial network is going to place it in concentric circles around what we call the parent nodes, so the main nodes. So this is very good where you have networks where you have a few key components in the middle, and then each one of those have lots of what we call child nodes. So it gets very complicated towards the edge. And within Insights, you can collapse those edge nodes as well, which makes it easier for you to maybe read and explore that chart that you're looking at. So they're the 3 different ways you can change looking at your link charts. Number of options available. So I've mentioned one of those that you can collapse the leaf nodes, the child nodes on the edges. You can also change the direction within a hierarchical one. You can also select the root node. So it doesn't have to be the main one. You can decide which is the top of the chart that you want to look at it. And in the radial chart, you can set your central node. So that would be the feature that you want to be looking at, what you're considering to be the most important feature. Set that as a center, and then all of the other features will radial around from that main feature. So now let's come to the centrality metrics, because this is actually the calculations, how we do the different calculations within the link analysis. So here I've worked through exactly how degree centrality works. It's the simplest of all the calculations. It's calculating which is the most connected entity. And we'll show you with those nodes that have the highest value are those nodes that have the most number of connections. So you can see where you have a node that have multiple of those links coming in, that's going to be the highest one. It is the most connected place, or person, or object, or whatever it is that you're actually looking at within that. The other useful thing that degree centrality can have is directionality. So it matters whether those links are in links or out links. So what that works is you can have nodes with higher out degrees. So where, for example, choices have been made and the information is flowing out. Or you could have nodes that have a higher in degree. So these are where choices have come in, they've been received. So these are perhaps more prestigious locations, people, events, whatever it is you're looking at within your link analysis. So the next measure we can look at is the closeness centrality. So this is for really finding influences within your link. So if you're looking at it in terms of people, those individuals that have high closeness centrality are those that are in a good position to control and acquire vital information or resources within the organization. You can also estimate how fast the flow of information would be given through a given node of other nodes. So another way of extending this, I haven't worked through this example, is using eigenvector centrality, and that depends on both the number of neighbors and also the quality of connections. So it's the important people connected to other people that have many connections flowing into them. So here I'm just showing how you work out those calculations. So in this case, it's calculating the number of nodes, and then by normalizing it, we're taking into account the size of all of that network that you're looking at within your analysis. So the last one to cover here, we've already done 3 of those different centrality metrics, is betweenness centrality. So this measures how often a node occurs along all of the shortest path between 2 nodes. Now, important thing when I'm talking about networks and distances, we're not talking about physical distance, we're talking about graph distance, so the number of steps across that graph. So that's one thing to remember. Easily confused when we're working in a geographic space to consider we're talking about distance. This is not, this is a graph that we're stepping across. So betweenness centrality is useful in terms of if you're looking at how information has been propagated, for example. So again, it could be used to determine the most important people within a social network. So it could be useful for analyzing communication dynamics and lots of other different features. So you could be looking at bridges within nodes if things break down. So what are the key things in terms of getting across that network? So the next thing I'll come on to, in complete contrast to link analysis, is regression analysis. So we have had regression analysis in Insights for a little while, but more recently we've expanded what we can do within that so that you can really understand how good your regression analysis model is. So at the moment we just use OLS, ordinary least squared regression. So that requires that you have linear relationships within your data. Remembering that regression analysis allows you to look at the relationship between a dependent variable and one or more explanatory variables. And we can also look at those, understanding those relationships, but we can also use it to predict within Insights. So there's the 2 different ways you can use that. You can find regression analysis through using the Find Answers, which appears from the Action button within Insights. So click on any of the chart or map cards, you will see the Action button in the bottom right-hand corner, and opening that will give you access to the spatial analysis tools and also Find Answers, of which in there, not all of them are spatial, some of them are non-spatial. So in there you see the regression analysis in there. So if you want to understand how good the relationship is between the variables that you're putting in, so 2 numeric variables, we can do that through a scatter plot. The scatter plot matrices is a way that you could actually explore this when you're creating a regression model because you can look at a number of different relationships at any one time. Another feature you can do within this is any one of those charts you're interested in, you can select that chart and drag it out. So you can further explore any one of these individual ones if you can't see it too small. And we also have the R² value showed in the top right-hand corner. So within OLS, you will only be looking at these linear relationships. And you can see here I've got examples of whether you have no correlation in your data, whether you have good correlation, and whether it's positive or negative within that data. So assumption of OLS. There are a number of different assumptions that must be met in order for you to use ordinary least squared. It's not that you can't technically run it, it's more a case of perhaps you shouldn't be using it. Because if it doesn't meet these assumptions, then likely the result you're getting is not accurate, and that's really not going to make creating a model of any value. So how can you check each one of these assumptions when you're using Insights? So here I've pulled out each of the different features. So first of all, the dependent variable, the thing that you're actually wanting to understand or model or predict in that variable. So first of all, that data needs to be randomly sampled. We also expect the value to have a straight line function. And you can look at both of those features by using a scatter plot. So that's the first thing you can do. When you bring in your explanatory variables, so these are the data that explain the dependent variables. So the other variables that you're using to, for example, predict that dependent variable. So these variables need to have negligible error in measurement. Well, that's not something we can test. That's really up to you to know your data. The effects on the dependent variable should not be additive. Again, that's something that you would know when you have this data, whether it has that feature or not. Another thing we want to look at is that it should not show collinearity with one of the other explanatory variables that you're putting in. This is where your scatter plot matrices kind of come in, because you're seeing those relationships, those scatter plots between all of the different variables that you're putting in. So you should instantly see whether there is collinearity with one of the other variables. The residuals, now these are the unexplained values in the dependent variable. These residuals should have an expected sum of 0. You will see that within the table. The residuals should also have homogeneous variance. You will see that if you create a scatter plot of the residuals. And remember I said earlier, all of the analysis that you do, we're giving you a result data set. So you will have those residuals output as part of that result layer that we've given you. So you can go in and create the scatter plot. You can look to see whether the residuals are normally distributed. You can use the histogram for that. So just drag those residuals to a histogram. And you also want to check if the adjacent residuals don't show autocorrelation. Well, we actually output that when we create the model itself. So you'll see, I just changed the next slide, that you'll see at the bottom there, we have the guide as to whether it has positive or negative autocorrelation, and we will fill that value in to show what the actual value is, so you're able to then interpret it and understand whether there is positive or negative autocorrelation within your model as a whole. So this is where we used to have, as much as we used to have in the previous version of Insights. So now we've expanded it a bit. We have always included the Durbin-Watson test. We now have the F statistic, the p-value, and importantly, we actually output the confidence intervals. So that allows you to not only see all of those individual values, so the coefficients, the standardized errors, the t-values, the p-values, the confidence intervals for each one of the explanatory variables, but again, working on the idea that it's easy for us to actually visually understand that information. We allow you to create a point chart around which we put those confidence intervals that are related to each of those explanatory variables. So you can see at a glance there, you can see those variables that have very wide confidence intervals. They're the ones that are not going to be so good at predicting because the value varies enormously. So that helps you to explore that. You can also run a number of different models, and then you can visualize those results together on the same chart. dragging that model across onto the first chart you create will allow you to picture it together and see how that model is changing as you're putting in and out different explanatory variables. So last but not least, in terms of the topics we're covering today, we're going to talk a little bit about using data science together with ArcGIS Insights. So how do we do that? So we do it perhaps a little differently to other places within ArcGIS in that we allow you to connect to your own Jupyter notebooks. So we're not asking you to move your workflows to a new environment, but you can start combining your spatial analysis together with your data science workflows by connecting these two things together. So how does this work? So a Jupyter notebook is a web-based interactive computation environment. It uses both the user interface and behind the scenes within your Jupyter notebook are also these things called kernels. So these kernels allow you to do the computation, and there are a number of different kernels contained within a Jupyter notebook. There might be Python, there might be R, there's C, Julia, there's lots of them. So what ArcGIS Insights does is it talks directly to these kernels. So effectively, we've put the interface into ArcGIS Insights, and then we pass that data to and from the Python or R kernel. So the interface you're getting within Insights is very similar to the one that you'd expect within Jupyter Notebook. So it's a very familiar environment, and it allows you to drag and drop any of your data sets or even the fields of information from Insights into your scripts and pass that information directly through to your Python or R kernel. So there you see the kernels are sitting in there. And how do we actually do that connection? Well, we do that through something called a kernel gateway, so the Jupyter kernel gateway. There is the way in which you can set all this up. We have a GitHub page for that. So if you look for the Esri scripting guide, and you'll find our GitHub page very easily, and that will explain how you set this up. Essentially, you're downloading it through either Anaconda or Docker, setting up that environment through which you talk from Insights through the kernel gateway to these Jupyter Notebook kernels. That's going to allow you to extend your analysis from Insights using Python and R, as I've already mentioned, manage your data in all sorts of different ways, and importantly also bring back any visualizations you create as cards. So you can drop those directly into Insights itself. So rather than me talking about this a little bit more, let's actually have a look at it. And Apurva is going to go through an example that will show how to use this. Over to you.
Thanks, Linda. Yeah, so we have Python and R scripting environment, which is supported in ArcGIS Enterprise and the desktop version of Insights. And we have added support to share the script as a model, which you can reuse to create your analysis or visualizations with different data in just a few clicks. All you need to do is set up your own kernel gateway, and the link to the installation guide is provided in the help documentation, which is very easy to go through. You can install it using Anaconda or Docker, and we recommend that using with HTTP connection when you are using with the desktop version of Insights for security reasons. But however, if you have your machine on which the gateway will be installed in your domain, or if it has a certificate signing authority, then you can use with HTTPS connection as well. So I'm gonna show a few examples how we can utilize power of Python or R within Insights. So I'm in a Insights workbook right now, and I have added a few data, like a couple of data sets. So this is where I access the scripting environment from Insights workbook. So I'm going to show an example using R code. I have car mileage data added into Insights, and Okay. So I added a R script which creates a ridge plot using the car's mileage data. So simply I can just drag and drop from Insights data pane into the scripting environment and execute this code. So what it does is it converts the data set into okay, let it process first.
So I think just to come in here, and great thing about it is you can load in whatever packages you want, because obviously it's your own setup, so there's no restrictions on whatever packages and stuff are being loaded in.
Mm-hmm. Yeah, so what this R code does is converting the data set from insights into an R data frame so that you can do further analysis on it. It uses, so as you can see, I added the generated output as a static card in Insights, and as you can see from the plot, um, we can know answers to questions which will be very difficult to understand from the raw data um, using the power of R. So it uses number of cylinders on the y-axis and city mileage on the x-axis, and we can see that like most or all of the 5-cylinder cars have their mileage around 20. That's where we are seeing a big and sharp spike in the ridge plot. And like for 4-cylinder cars, the city mileage is widely distributed from 15 to like almost 40. For 6-cylinder cars and 8-cylinder cars, the mileage is less than 20 for most of the vehicles, and for 6-cylinder cars, the mileage is in the range of 16 to 18, and for 8 cylinders, it's in the range of 12 to 14. So we can create visualizations, or you can bring in data sources for which built-in support is not there in the Insights application using the Python or R scripting environment. Um, so I'll save that work, and I'm going to show a different example. So here also I just simply need to bring in my data um, by drag and drop into this scripting environment, and this code creates a 3D regression plane using the same car's mileage data, where it takes like cylinders on x-axis, city mileage on y-axis, and it takes the highway mileage on z-axis. So if like after I execute this code, it generates a beautiful 3D plot.
We hope.
Yeah, and there it is. So it creates this 3D scatter plot where it creates a model for highway mileage. It takes the available data as training data set, and it creates a model to predict highway mileage. If we keep adding new data sets, and if we don't have the highway mileage value, then this model is very useful. And we can create a lot of different visualizations like this using Python or R scripting environment within Insights. So like these two examples were using the R code, and now I'm going to show an example using Python code. So let's switch to the Python kernel. And this is, so I have Yahoo stock data from 2012 to 16 for the 5 years period for each trading day. And this code converts the insights data set into pandas data frame, takes as input the closing price of Yahoo stock, and creates a calendar plot using that data. For that also, I simply need to drag and drop my Yahoo stock data into this code and run the code. So this code created a calendar plot for Yahoo stock data, and it shows that the stock was in the range of 10 to 40, and it helps a lot to understand the patterns of the stock price. We can see that it had a spike to its all-time high value in August of 2015, where it reached to almost 40, and then it dropped again. And later in the year, it started showing recovery in the early 2016 by showing the values in high 20s and low 30s, but then it dropped again to low 10s in end of 2016. And now I'm going to show example of the um, sharing script as model capability. So let me go back to the scripting environment. I can select the cell and click on add to model, which adds that script as a model. It shows up here. I can give it a meaningful name, and I can share this script with my organization. And for example, I have Yahoo, Apple stock data, which for which I want to use the same model which I shared without doing any code, and with just few clicks using Insights. So I can simply add that model back from add to data model, and now I have Apple data in a different page. I can just click on run and select Apple stock value.
So this is running that same model that you've shared back
Mm-hmm.
to the portal, to Enterprise, and now
Mm-hmm.
you've downloaded it and run it with a totally different data set.
Exactly. So the same calendar plot is created for Apple data now, without you need to go into this scripting environment, and without needing to write a single line of code. And I can copy and paste this card of Yahoo dataset to have a side by side comparison, um, to showcase the power of Python or R in Insights. Thank you.
Cool, thank you, Apurva. So we saw quite a lot in that. So we saw how we can connect to both Python and R. You switched the kernel between the two, so we can combine the results from Python and R in the same workbook, the same page. We can also add in those models into our workflows. So we can add that into, you know how Insights already records everything you do, that model is going to be dropped into your Insights model as well. So, or you can just share it straight out as we saw in the example, and other people can make use of it, use it with different data sets, different fields. So there's an awful lot that you can do. And remember, we were also seeing how you were dragging that data from the data pane, which is sending it through to that kernel, doing the processing in that kernel, and then we're seeing the results back. In this case, the results that you were working with, you were showing as the different charts, which is great. One great use of it. Another way you could be using it is bringing back another data set. So we could be concatenating data, stripping out nulls or whatever data management things we have to do when we build up that data. So that's another way you can use it, by sending data through to those kernels, manipulating it there if you have a script that sort of makes that job easier, and then bring the results back in, so you can then bring those results back in with just a single magic command that we've built. All of that's in our documentation, so you can bring data in and out. So it's another great way that you can use that connection. So the last thing to talk about in terms of it, we've talked about the sort of the more advanced analysis. We gave you an introduction to insights. We talked about link analysis, regression. We've showed you the Python and R. Well, we've done some great analysis. We've shown all the functionality. Well, obviously we need to share that out. So let's talk about what we can do in terms of sharing out all of the results and analysis we do. So the first thing I wanted to talk about is the fact that we've tried to integrate this as much as possible with the analysis. So it's not like there's a whole new environment you go to. It's just that you create the pages you want. You can share that back out to others, but you can also go back in and change the analysis in there. There is that ability to do all of that and then share out the new one. So it's very much an integrated experience that you're working with. Lots of different parts of sharing you can do. You can share the data sets out. You can share the workbook so everyone can see everything you've done. Remembering that's taking the model with it so they can see that. You can share out pages. You can share the models. You can create packages in desktop now, so you can share from one desktop to another. And coming soon, there's going to be more work on that. You'll be able to create packages and share across all the different environments that we're doing. But I'm already jumping ahead and giving you a sneak peek there. So in terms of whether the data is connected or not, that will, whether it's live or not, that depends on the type of data you're working with. It also depends on whether you have cross filters already set up within your data. So you set up cross filters if you want people to explore that data and for it to filter out, to show based on the interactions they're doing. Remember, interactivity is built in, but that's allowing you to see the data selected out rather than filtered out. Subtle difference, but very important. You can change your axis labels. So you can go in and change the naming on all of those axes to being something a little more friendly. You can create pop-out legends. Remember to add in those legends on those maps so other people can see what everything means on the map. You can change the foreground and background color on the page as a whole and as on any of the individual cards. You can add in a filter widget, so it can be a single select or a multi-select in terms of the filter. And on the text and media widget, you can go in and you can add explanations that will help people understand what you've written. You can add in videos, you can bring in images, icons. So there's lots of different ways in which you can build out that page that you're sharing it with. There is also something called the Insights Gallery. You can get to that from our homepage as well if you're looking for inspiration. Lots of great examples that people have built out, and you'll be able to see the many different things that you can do when you share out your analysis. So now probably the most exciting bit for those people who are currently using Insights, what are we working on now? So we're working on lots of different things. These are the things that I'm confident to share with you. So in terms of the data, what's going to change on that? Well, the big ask, and we have listened to you all, has been, please, how can I auto-update my analysis? So we're working on that. We are going to introduce a way in which you can schedule that analysis so that it will rerun. Remember, this is rerunning all of the analysis that you've done, a little bit more than a dashboard. So it's not just changing how it looks, it's doing all that. Remember, we talked through the visual analytics. It could be doing all of that, re-aggregating data, what is it that you've done. You'll be able to schedule when you want that to happen. I already mentioned how we're packaging data, works on the desktop already, but we're soon going to be packaging it so you can work between all of the different deployment methods that we have of Insights. You'll be able to connect directly into your SharePoint lists. We will give you direct connect to OneDrive, and we're also adding in OS authentication for SQL Server databases. In terms of the analysis, we're going to make improvements to kernel density. So that's going to work hopefully much better. Results are going to be more valuable for analysis. And, well, there's lots of exciting things. I don't want to give it away because I'm really excited about the work we're doing on the kernel density. We're also going to be introducing clustering, both spatial and non-spatial clustering. We're going to be adding labels on your bar charts and your column charts, another big ask from people. And on the combo charts where you can see two different data sets together on one chart, we're going to allow you to sync those y-axes so you can compare the two. At the moment we're auto-scaling them, but we'll allow you to do comparisons with those charts. In terms of the presentations, we're going to add in drop-down filters. Again, that was another ask for those of you who had very, very long lists you want to filter between. You'll now be able to change that to a drop-down. You'll be able to change the font across the whole page. You'll be able to order the cards, so which card is on top of another. Again, this is to help you with your presentation. We are also tidying up a little bit of work on the legends and allow you to have a little bit more functionality in how those legends work. So now the sneak peek for what we have already done. So we've included a search for any of the fields you're looking for on the data pane. So if you want to find a particular field, we're going to have that search in there and you'll be able to find that easily. And one last thing in terms of what we've already done is we also allow you to change between the page tabs. So currently when the order in which you drop in your pages is fixed to that order, but we have already at the next release, you'll see it, being able to put in that ability to move those pages. So you'll be able to reorder those pages that you have within your workbooks. So that's all we have to go through today. Hopefully you learned a little bit about how you can use insights within your analysis, and also we've given you a little sneak peek into what's coming up in our next release, which the whole team is really excited about. Thank you very much.